The importance of this work is to try to figure out what happened to the oil. Many people have speculated that the oil stayed in the water column, some of it went to the bottom, some of it of course ended up in the beaches, some of it was burned at the surface. We're here in the Gulf of Mexico, near the Deepwater Horizon disaster site. We've been here for a few days with a team of scientists investigating the chemistry of the water, doing some tests of the sediment, and the objective is to look at what remnant of the oil spill is still here.
The reason we came out here basically is to come up with a mass balance of how much oil was put into the system and how much is still in the water column, how much is on the sediment surface, and how much can we not account for.
4 scientists have now joined us from Texas A&M. The team includes biogeochemists and benthic ecologists. Together they will be investigating the fate and impact of the oil, both on deep water and on the ecology of the seafloor. We are deploying probes up to 2 kilometers below the ocean's surface. A CTD probe contains a number of instruments which measure physical and chemical parameters, and also can be used to capture 10-litre water samples.
These scientists are looking at a variety of things, including dissolved oxygen and chemicals in the water and the salinity, changes in temperature.
We've been focusing on the dissolved oxygen concentrations. We have a pretty good idea what the regular or normal profile looks like, and so if there's deviations from that profile, that's the depth levels that we focus on for sampling, for doing analyses on hydrocarbons, dissolved organic materials, but also dissolved inorganic components in order to see the leftovers of the oil spill. The more oil and gas that has been degraded by bacteria, the more oxygen would have been consumed. And on the transect here, we were able to trace that oxygen deficit basically over the entire stretch, about 500 kilometers so far. And you have relatively low oxygen consumption near the wellhead right now. Traces of oxygen consumption about 500 kilometers out, and somewhat higher oxygen consumption in the center here. And that is interesting because if you would assume that we are looking at a continuous current going from the wellhead to the west, and if you would assume that bacteria degradation is the main pathway by which those oil and gas components are removed from the environment, then you would expect that your oxygen concentration would continue to decline along the transect, and that's not what we are finding here.
And what we're moving on to today is, after we've done some extensive water columns research, is we're going to try and get some mud. And primarily that's so that we can get down and see what's going on with the animals.
And we're taking samples of the bottom of the Gulf, the mud and sediment and the living creatures that are down there, using a large metal contraption called a box core.
So this monster works by basically going down to the bottom, and it's got the jaws open, and once it hits the sea floor, there's slack created on the cable, and that's going to allow those jaws to be drawn up and shut so that we bring back a nice big chunk of mud, and you'll see that once it gets on the deck that we're actually bringing back a good piece of the seafloor with us. Yeah, we're just going to drop it in the cradle here. Get it set down on the deck so we can process it. And now for the moment of truth. So we've got lots of good water on top and a really good mud depth too. First thing we put in before we disturb it too much is going to be this geochemical core. Yeah, we want to get a little bit of that overlying water. We're going to go ahead and take this X-ray core for some geologist friends of ours. And what we'll be able to tell once we take it back to the lab and they do some X-rays of it, we'll be able to see some animal features on the surface, like burrows of worms, And then for the geologists, what it tells them is just how long this mud has been there and how fast it's accumulating in the sediments. So this is how we keep from losing anything, is it's going through a sieve. Right, so this jar here is for PAHs, and that's how we measure hydrocarbons in the sediments. Before we grab everything out, we've got a little modified core here that we're going to be able to extract some mud for some really small invertebrates and nematodes. I'm going to pick a nice looking little muddy area. So that looks like a good core. And you can see below, just a couple of centimeters, it turns into that dark gray clay. And above that, it's all nice brown material that's recently sedimented. So before oil and gas exploration was opened up in this area of the Gulf at these depths, we did a baseline survey to get a handle on the populations of the different invertebrates that live there, as well as the fish and the larger things like squid and crab that live right above the bottom. And one of the things that you never think about as you're doing that is that you're going to have to come back out and actually look at that after there's been a major spill or some other type of environmental disaster.
The data that we're collecting today will be compared to the older data to see if anything's changed, especially if anything's been affected by the oil spill.
When we sit down and look and compile all the collected data, we will be able to estimate how much of the oil and gas was actually consumed.
And the studies we're doing today, the samples we're taking, will help to add to the body of knowledge of where the oil is and what the long-term environmental impacts are.